Hello students and welcome back to the Medicinal Plants series of videos. Today we're going to continue by talking about the toxicity we can find in medicinal plants, as well as the adverse reactions and the possible interactions. So expect to learn what are the different types of toxicity, as well as the different types of adverse reactions due to medicinal plants, and the different types of interactions we can find together with pharmaceutical drugs. Hi, I'm Tommy. I'm a human nutrition student and researcher at the university. What I do in this type of videos is to synthesize my classes so then I can explain and teach you the best and most valuable information you need to know. So let's begin by talking about the toxicity we can find in medicinal plants. Toxicity of medicinal plants. The plants have active ingredients, as we saw in the last video. Therapeutic effect and toxicity can be quite close, and children are the most affected by this. They eat everything and they are not fully developed to counteract this toxicity. What are the types then? We have the first one, which is gastrointestinal toxicity. This is vomits and diarrhea. It happens when we have plants rich in saponides and can also cause mild gastroenteritis. And we can find this in the Euphorbiaceae, such as the genera Euphorbia, Mercurialis, Croton, and Epomenae. The tree of death, indeed. Cardiovascular toxicity, we have cardiotonic heterocytes. Do you remember those? We use them in heart failure treatment. This is the digitalis. They have a narrow therapeutic margin, and accumulation in the heart muscle can be dangerous. On the other hand, we have the diterpenic alkaloids, another type of alkaloids. We can find them in the aconate and yew. Indeed, this is the taxus. And in case of intoxication, we can have a severe neurotoxic and cardiotoxic effects. Anticholinergic syndrome. For example, the Solanaceae contain tropine alkaloids, which can be very toxic. Again, alkaloids. Do you remember that I said that alkaloids are very toxic? You have a demonstration here. Intoxications by Solanaceae can be very serious, but fortunately enough, they are rare. The peripheral effects we can find are facial flushing, dry mouth and mucous membranes, hot and dry skin, fever, mydriasis, urinary retention, abolition of intestinal noises, tachypnea and tachycardia, and the effects on the central nervous system, agitation, motor incoordination, seizures, visual hallucinations, unintelligible speech, they are not able to speak properly, disorientation, lethargy, and a possible coma with respiratory depression. And then the nicotine syndrome. This happens when we find plants with piperidine, pyridine, and quinolizidine alkaloids. Again, alkaloids. Intoxications are serious but rare, fortunately. The ingestion of cigarettes, skin absorption, and confusion with other medicinal plants are the main reasons of intoxication. The effects on the autonomic nervous system, so this is sympathetic and parasympathetic. We have hypersalivation, lacrimation and sweating, nausea, vomiting and diarrhea, bronchospasms and arrhythmias, as well as hypertension and maybe hypotension, depending if they are acting on the sympathetic or parasympathetic. And the effects on the central nervous system, we have vertigo, seizures, paresthesias, fasciculations, weakness, and progressive muscle paralysis. As you can see, alkaloids are very, very toxic. And then hepatic toxicity. Plants with pyrrolizidine alkaloids. We already talked about pyrrolizidine alkaloids, another type of alkaloids. Intoxications are rare and they can occur because of abuse of plants or contaminated cereals. These pyrrolizidinic alkaloids can have hepatotoxicity, pneumotoxicity as well. Pneumotoxicity is pneumonia, emphysema, and edema, and nucleotoxicity, mutagenesis, carcinogenesis, and other effects of the nucleus. Hepatotoxicity, which is what we are talking about here, is chronic hepatotoxicity, maybe an hepatic veno-occlusive disease, an hepatomegaly, or a cirrhosis. So 4 types. Pyrrolic metabolites in hepatic microsomes are the ones that produce the toxicity, and the pyrrolic derivatives act as alkylating agents. And we can find these pyrrolizidine alkaloids in flowering tops of borage, the root of comfrey, the whole plant of senecio, and the floral head of coltsfoot. Cyanide toxicity, toxic plants with cyanogenic glycosides. 2. Hydroxynitrile glycosides. These are derivatives of amino acids. So, alkaloids, again, they suffer an hydrolysis and they produce hydrogen cyanide, which is the toxic compound. This toxicity happens when there is a rapid ingestion of large amounts of plants rich in cyanogenic glycosides, such as cassava and bitter almonds. The symptoms are vomiting, abdominal pain and diarrhea, changes in respiratory rate, headaches and dizziness. And there are disturbances of consciousness, deep coma, and respiratory depression. Then we have oxalate toxicity. We have soluble and insoluble oxalates in plants. The solubles are the worst one. Plants such as rhubarb, sorrel, and the now famous starfruit, which we use in salads. So what can oxalates do? Irritation of the oral and digestive mucosa. And the soluble ones, gastrointestinal disorders, hypocalcemia, renal damage, which indeed are kidney stones, and lesions in liver and brain. These also affect the veterinary medicine because they are dangerous for livestock. They are serious damage if consumed in large quantities for them as well. So be careful with oxalates. Then we have glucosinolates. These are found in brassicas, such as cabbages, mustards, and black radish. When crushed or broken, there is an hydrolysis by specific enzymes, and this will create sulfur compounds that have goitrogenic properties, so an enlargement of the thyroid. And then toxoalbumins. This is a group of highly toxic glycoproteins. There's a low natural availability, and it's only found in certain seeds. We can find it in the castor bean, the jequity bean, and the mistletoe. And the ricin can be a bioterrorism weapon. What it does is abdominal pain and vomiting, diarrhea and gastrointestinal bleeding, dehydration and shock, meiosis and cramps, liver and kidney damage, and convulsions, coma, and even death. That's why it can be used as a bioterrorism weapon. Now it's time to talk about adverse reactions of medicinal plants. So there is an increased consumption as self-medications of medicinal plants because many people believe that natural is safer. But in reality, they should be actually considered as proper medicines because they have adverse effects, interactions, and contraindications. And they should require the same safety guarantees as all the medicines. So what are the types of adverse reactions we can find? On the central nervous system, we have hallucinogenic and anticholinergic effects, such as headaches, hyperexcitability, or drowsiness. And plants that can alter the central nervous system are the valerian root, that causes withdrawal syndrome when prolonged use, the fruit of star anise because of atenolol, which has a neurotoxicity in children, tuyona, tuya, sage, or absinthe, which can give convulsions, the pineocampone, the hyssop, convulsions as well, aerial parts of ephedra, headaches, anxiety, tremors, and insomnia, and the cassava rhizome, which is a cyanogenic heterozyte, which can give the conzo, which is indeed a paraparesis. It is a partial paralysis of the legs. And last but not least, we have the lathyrus seeds. And because of the ODAP, we can find the neurolatherism, which is a leg rigidity with a later paralysis. So as you can see, we can have very serious adverse reactions. Dermatological, we can have pruritus, skin rash, and urticaria. Also an allergic contact dermatitis because of aloe vera gel or garlic bulb. Some people are allergic to those. And then we have a thing called photosensitization, which is indeed the sensibility to light. The bergamot, celery, and figs are furanocoumarins, and if you remember, furanocoumarins have this photosensitization property, as well as the St. John's wort, the Hypericus, which has naphthodiestrons. The anica flower as well has sesquiterpene lactones, and these, together with sunlight, they can cause acute dermatitis, vesicles that can become blisters, and hyperpigmentation of the skin. And in case of the anica, we can go from vesicles to even necrotic lesions. So we have to use it very, very diluted. And then we have hepatic adverse reactions. So the liver is highly susceptible to a wide range of injuries, and it's a highly exposed organ because the majority of xenobiotics go through the liver. Clinical manifestations of hepatotoxicity, we can have three mainly. The hepatic veno-occlusive disease, which is caused by unsaturated pyrrolizidine alkaloids, again, that we can find in the borage, comfrey, senecio, or coltsfoot. We talked about this before. Chronic hepatitis, wall germander flowers, for example. These were used in weight loss diets in the 90s, and now they are banned because they could cause hepatitis. Cholestatic hepatitis, and this is because of kava roots. They come from Polynesia and they have anxiolytic properties. But when we imported them to Europe, we started viewing some hepatic toxicity effects. So it was banned in 2001. And then there is a suspension of the commercialization of certain medicinal plants, such as the ones with ethanolic dry extract of green tea leaves with 25% of catechol and 5 to 10% of caffeine. Because in 2003 there have been cases of cholestatic hepatitis and steatosis because of these medicines. And then nephrological, so the kidneys. This is another organ closely involved with xenobiotics detoxification. It's especially prone to the toxic action because of that. And we can find irreversible nephropathies and nephrolithiasis, which are kidney stones. So the nephropathies can occur with the species of Aristoloca genus, which was prohibited in 2001. And aristolochic acid, which is the main compound, is linked to kidney damage and disease. This was found in Belgian women that used the treatment with Chinese herbal medicines for weight loss. On the other hand, the kidney stones can appear with a species of ephedra, because ephedrine, which can generate nephritic colic by precipitating in the renal tubules. But fortunately enough, it's infrequent. And then endocrine system. So these adverse reactions are not very frequent, but they can occur because of the consumption of iodine-rich algae, such as Fucus thallus, and it was recommended in certain weight loss regimens, and this can give hyperthyroidism. Ginseng root, the ginseng abuse syndrome, which is formed by anxiety and irritability, nervousness and insomnia, hypertension, and morning diarrhea with skin rashes, very pleasant. This syndrome also has estrogenic effects, and that's why we need to keep the ginseng root consumption below 2 grams per day. Another root is the licorice root, which can give us a pseudo-hyperaldosteronism. This is muscle weakness, hypertension, hypokalemia, water and sodium retention. This is because of the glycyrrhizin and genin, which are the active ingredients. These are enzyme inhibitors and they have corticoid effects. We have to keep the consumption below 1 to 3 grams of licorice per day, which is equal to 200 milligrams of glycyrrhizin a day. Other types of adverse reactions we can find are the gastralgia, which is due to the presence of tannins, saponins, and or essential oils in the butcher's broom or horse chestnut, slight laxative effect of the devil's claw root. Stimulant laxative drugs of the colon. These are androxyanthracene derivatives, which can be found in the senna leaves and aloe vera gel, and they can cause a blackish discoloration of the colon together with the lazy bowel syndrome. Then we have the ginkgo leaf, which can give us headaches, dizziness, digestive disorders, and allergic reactions. And the garlic bulb, which is correlated with digestive disorders, dermatitis, and the characteristic odor in breath and sweat. As last chapter of today's video, we talk about interactions of medicinal plants. The pharmacological interaction is basically a modification of the drug effect by presence of another agent, such as drug, food, medicinal plant, or even environmental factor. You have to know that potentiation of these effects have been used for therapeutic purposes as well. The most worrying interaction is with medicinal drugs, because there can be a reduction, so it can be ineffective, or a potentiation, which can lead to toxicity. Many drugs have a narrow therapeutic margin. We already talked about that. And we have to avoid plants in post-operative stages, because we are full of a lot of drugs, and a lot of interactions can occur. The knowledge we have on interactions is limited, but sufficient enough to recommend a vigilant attitude. So, knowing that, what are the types of interactions? We have pharmacokinetic interactions and pharmacodynamic interactions. Pharmacokinetics, they change the parameters that condition the plasma concentration. Absorption. The medicinal plants usually reduce the drug absorption, the pharmaceutical drug absorption. This is done by altering digestive pH, speed of a gastrointestinal tract, or via non-absorbable complexes. They can be resolved by separating the administration, so to not take them together. And here we have the anthraquinone laxatives, the aloe vera gel, senna leaves and fruits, the buckthorn bark, and the Cascara Sagrada bark. They increase the gastrointestinal transit speed and they reduce the absorption because of that. And due to the hypokalemia they produce, they can interact with the cardiac glycosides. This is the digoxin, increasing the toxicity, with antiarrhythmics, kinidin, increasing the arrhythmias, with thiazide diuretics, and also with corticosteroids and licorice root, which has to do with electrolyte balance. Mechanical laxatives, we have psyllium seed and guar gum. They absorb multiple active ingredients, adsorb, and they prevent or delay their absorption then. Then we have spicy drugs, such as cayenne fruit, black pepper, and ginger root. They increase the drug absorption and bioavailability. So as you can see, these are the only ones that will increase the absorption. Then we have the metabolism. So enzymatic inducers and inhibitors. The inducers decrease the therapeutic effect because there is a greater metabolism, whereas the inhibitors, they increase the toxic therapeutic effect because there is less metabolism. And inducers, we have the St. John's wort flower, the Hypericus, which is a cytochrome P450 enzymatic inducer and will lower the therapeutic effects of many drugs. And we must be careful when stopping using the St. John's wort as the toxicity may occur. And another inducer is the garlic bulb, which will lead to a therapeutic failure because it will lower the effects of many drugs. Enzymatic inhibitors, we mentioned the grapefruit juice. It's one of the main inhibitors of the cytochrome P450. There is less metabolism and therefore higher toxicity. On the other hand, we have the pharmacodynamic interactions. These are alterations of the pharmacological effect, either an increase, synergism, or decrease, antagonism. So here we have the serotonin syndrome, which is a tremor, behavioral changes, vomiting, headaches, and myalgias, due to the St. John's wort, the Hypericus, the extract from the flowering tops to be precise, together with the antidepressants. It's because of a similarity in the mechanism of action here. Photosensitivity, again the Hypericus wort flowering tops, together with known photosensitizers, such as sulfonamides, tetracyclines, quinolones, and thiazide diuretics. Then hemorrhagic phenomena. This is the garlic bulb or ginkgo leaf, together with oral anticoagulants. They will increase effect, they will have a synergic effect, leading to hemorrhages. And then the hypoglycemia and the oestrogens. So garlic bulb and ginseng root this time, together with hypoglycemic agents, will indeed create the hypoglycemia. And there is a higher toxicity of estrogen agonists together with the ginseng root. So to recap, knowing the drug and the plant, we can predict the interactions, but not the clinical relevance. So it's important to treat each case as an individual and unique. Okay, this is it for this video. I hope you understood everything I said. If you didn't, there is a comment section down below. Don't forget to like, subscribe, and turn on the notifications so you get notified every time I upload a new video. Thank you so much for watching, and I will see you in the next one, in which we're going to talk about the plants in the central nervous system. So stay tuned for more information on medicinal plants. Ciao, hope you enjoyed.